We have a leaning ladder here, leaning against the building, and we have an angle of 72 degrees that ladder forms, and we simply want to know what is the height that ladder reaches on the building. Where do the tips of that ladder land? This is problem page 489, problem number 57, if you want to look at that. And check our work by looking at the answers in the back. Now what I'm going to do, I'm still going to hold a little bit to that unit circle. I'm going to draw that unit circle. And I want you to realize we have this triangle here. 20 is the length of the ladder. H is the height that we'd like to know. Well, I don't think we need the x coordinate, but I'm still going to put this triangle, embed it into the unit circle. So you can see here's 72 degrees. Now, you may recall from the other problem that we had about the shadow on the building, that was an angle of 18 degrees. Well, lo and behold, my numbers are very similar. And they're exactly the same, actually, they're just switched. Now my sine value is 0.951, and my cosine value is 0.309. So I can, what's different here is in this unit circle, this height here is 1. But I still have the same setup. 0.951 is the height when that length is 1. This height here is going to rely on that length 20. So I can write h over 20, which really is the sine of 72. It's I'm going to say it for the first time, opposite over hypotenuse is h over 20. That is equal to the sine of 72, which is over here in my unit circle, which is 0.951. So all I have to do to get h is multiply both sides by 20, and I get 0.951 times 9. That's going to be 19.2. I think. You can check me out. I did that in my head. But that says that a 20-foot ladder reaches 19.2 feet on the side of the building. Check me out, but that's the answer that I get. Again, I want to point out we have the ladder triangle here. We have our unit circle triangle here. They are similar triangles, which means the ratios are the same. So my ratio here is 0.951 over 1. My ratio here is h over 20. Those two ratios are the same, so I can use that to solve for h.